And it's a beautiful sunny day, and I'm going to talk to you about velocity versus time graphs. This is your constant acceleration packet, and this is questions 11 through 14. So let's start with 11. I have a position time graph. Remember, the slope of a position time graph tells me the constant velocity. So I can find the slope of this graph. It's the change in position over the change in time. We can see that that is 4 meters over 4 seconds. So this object is moving at 1 meter per second. It's a positive slope, so we know it's in the positive direction. Okay, I can also find my displacement from this graph. Remember, displacement is my final position minus my initial position, which is 4 meters minus 0 meters. So my displacement from my position time graph is 4 meters. Now I know it's moving at 1 meter per second, so I can draw that on my velocity time graph. That is just for 4 seconds, it's moving at 1 meter per second. It's a horizontal line. It's a constant velocity of 1 meter every second. I can find, check this out, I can find the displacement from a velocity time graph. Yes, I can. To do that, I find the area from the curve down to the horizontal axis. So I can find that area. That would be 1 meter per second times 4 seconds. Units are just like numbers in that they divide and multiply. I can reduce seconds divided by seconds to 1, so I can say my displacement is 4 meters. The same as my position time graph, because they are showing the same motion. Okay, so let's go on to 12. A little bit more difficult because this object is changing direction. This has a positive slope, so I know this is in the positive direction. This is a negative slope, so I know this is in a negative direction. Okay, again, the slope of a position time graph tells me my average velocity, so I can say for the first 2 seconds, I can look at my slope and I can see it's moving 1 meter per second. For the next 2 seconds, I see it's a negative slope and it's moving at negative 2 meters per second. Remember, the slope tells me my average velocity. Since the velocity is constant, the average velocity is the same as a constant velocity. So let's put this over on the velocity time graph. For the first 2 seconds, I'm moving at 1 meter per second. And for the next 2 seconds, I'm moving at negative 2 meters per second. All right. So let's find the displacement from the velocity time graph first this time. Again, remember, it's the area from the curve to the horizontal axis. So this area right here is 1 meter per second times 2 seconds. So that's 2 meters. Now, this one, we're going to find the area, remember, from the curve to the horizontal axis. So this area right here is negative 2 meters per second. That negative is really important. That is just the direction. Times 2 seconds gives me negative 4 meters. My displacement is just the sum of these. 2 meters minus 4 meters. So my displacement is negative 2 meters. We should get the same thing on the position time graph. Let's look. The change in position is my final position. 0 meters minus my initial position, 2 meters. So my displacement is negative 2 meters. Same displacement because the two graphs are showing the same motion. Okay, So we've done constant velocity in one direction, constant velocity in two directions. Now we just learned in this unit that when I have a position time graph and it has a curve, then that means my velocity is changing. And we learn when it's shaped like this, we can call this increasing speed in a positive direction. All right, so now we have to put this in the velocity time graph. So first of all, we know it's a positive direction, so the velocity is going to be above zero because it's positive. And we know it's not going to be a horizontal line because it's increasing. So what I did was I made a line tangent to my position time graph at 2 seconds right here, and then up here at 4 seconds. So I'm going to find the slope of the line at 2 seconds and 4 seconds. So the blue one, my slope right there is my change in position over my change in time, which is 3 meters minus 1 meter over, I'm sorry, that's not what it is. It's 2 meters minus 0 meters. I was looking at the seconds, sorry, my bad. 3 seconds minus 1 second. So my slope right at 2 seconds, is 1 meter per second. So I know at 2 seconds over here on my velocity time graph, my object is moving at 1 meter per second. Okay, so now let's look at the slope at 4 seconds. I'm going to draw it over here. At 4 seconds, the slope of my line is 4 meters minus 0 meters over 4 seconds minus 2 seconds. So my slope of the line at 4 seconds is 2 meters per second. So over here on my velocity time graph at 4 seconds, I'm moving 2 meters per second. I also know that at 0 seconds, the slope of my line is 0, so I'm not moving. So that right there would be what my velocity time graph would look like. Okay, and that's what it looked like when we did that simulation. So this is all good. This still makes sense. So let's look at the displacement. First, the velocity time graph. Remember, we're talking about the area, right? The area from the curve to the horizontal axis. So this area right here, it's a triangle. So it's 1/2 base times height. 1/2 4 seconds times 2 meters per second. So my displacement is 4 meters. Let's look and see what it is on my position time graph. I'm going to write it up here so we can see it at the same time. My displacement here is, again, 4 meters minus 0 meters. So my displacement is 4 meters. Same displacement because we're talking about the same motion. Okay, so the big ideas from this, we do a lot of graphs. For many graphs, both the slope of the line and the area between the line and the horizontal axis have physical meanings. We've done that before and we'll do it again. So the position time graph, the slope tells me the average velocity. Okay, when it's a constant velocity, the constant velocity is the same thing as the average velocity. All right, so then it says, looking at the velocity time graph, what is the units for a square on the graph? So if you looked at each one of those squares on the graph, the vertical part of that square would be 1 meter per second, and the horizontal part would be 1 second. So the area of each one of those is 1 meter per second times 1 second, or 1 meter. Each unit of the square is 1 meter, and the unit is meters. Okay? All right, then it says, what does the area under the velocity time graph tell you about the motion of the object? And I hope you're all saying it with me together. It says the displacement. Okay? That's what it tells you, the displacement of that object. All right, everyone. I hope you enjoyed this, and I hope you have a great, great sunny day.